Hello students, this is a video on the topic tests that we at Bodhee Prep have for you. Now these topic tests are designed to help you evaluate your situation with respect to a topic. So once you've done the basic concepts of a topic, you write these tests and understand whether you're able to do those questions in the exam format or not. Uh, with every test there is a video. So once you take the test to go through the video will give you the solutions, number one, and a brief analysis of how you should have taken that test like an exam in terms of difficulty level, in terms of time. There are more than 200 such topic tests available on the Bodhi Prep Android app. The link for the app is in the description of the video, so make sure you download the video or the app and make the most of these tests. This video is on trigonometry. This is the first test on trigonometry, and in terms of level of difficulty, it's an easy to moderate sort of a test. Basic concepts of trigonometry checked. About 6 to 7 out of 10 questions would be a good attempt, 95 percentile plus, and time taken should be somewhere around 20 minutes, a minute here and there. So if you look at the questions, question number 1 says 1 plus cos A upon 1 minus cos A is equal to m square upon n square. Find the value of tan A. We can put a value of cos A here from where we can get the ratio of m and n. For example, if I put cos 45, I'll get the value of m square n square. I can put that in the options and check. Not the best way of going about the question, but that can be done worst case scenario. How I would solve this question is because I have this kind of an expression on one side. We use componendo and dividendo, which says if a by b is equal to c by d, then a plus b upon a minus b is equal to c plus d upon c minus d. Componendo and dividendo together. So here, numerator plus denominator will give us 1 plus cos a plus 1 minus cos a upon 1 plus cos a minus 1 plus cos a is equal to m square plus n square upon m square minus n square. This becomes 2 upon 2 cos a is equal to m square plus n square upon m square minus n square, which further means cos a is equal to m square minus n square upon m square plus n square. Now if we square this, we'll get cos square a is equal to m square plus n square, m4 rather, m square square plus n square square minus 2m square n square upon m raised to power 4 plus n raised to power 4 plus 2m square n square. Cos square a is nothing but 1 minus sine square a is equal to m raised to power 4 plus n raised to power 4 minus 2m square n square upon m4 plus n4 plus 2m square n square. Taking sine here, sine square on the right hand side, this expression on the left hand side, we can get sine square a is equal to 1 minus this entire thing. If we do subtract 1 minus this expression, we will get m4 plus n4 plus 2m square n square minus m4 minus n4 plus 2m square n square upon m4 plus n4 plus 2m square n squared. And therefore sine square a will be nothing but 4m square n square upon m square plus n square whole squared. And therefore, if we take the root, we'll have sine of a is nothing but plus minus 2mn upon m square plus n square. Tan a is nothing but sine a upon cos a. And therefore, if we divide this, you'll get plus minus 2mn upon m square minus n square. M square plus n square will cancel out from both of them. And therefore, option B becomes my answer. Again, writing the expression takes time. In terms of level of difficulty, not more than a moderate level question, should be able to do this within about 2 minutes. Sine 600 into cos 30 degree plus cos 120 sine 150 is k. Find the value of k. Now 600 is nothing but multiple of 180. So 3 into 180, 540 plus 60, 30 is 30, 120 can be written as 90 plus 30, 150 can be written as 180 minus 30. And therefore this expression becomes sine of 3 into 180 plus 60 into cos 30 plus cos of 90 plus 30 into sine of 180 minus 30. All of them are in degrees. Because this is a multiple of 180, sine will remain sine. This will be in the first 360 is one complete circle, 180 is the third. This will be in the third quadrant and therefore negative. So minus sine 60 cos 30. Cos 90 becomes sine. This is in the second quadrant, so cos will be negative. Sine 30, this is 180, therefore remains sine. 180 minus 30 second quadrant, therefore sine 30. Sine 60 is root 3 by 2. Cos 30 is root 3 by 2. Sine 30 is 1 by 2. Sine 30 is 1 by 2. So minus 3 by 4 minus 1 by 4, which is minus 4 by 4 or minus 1. Option C becomes the answer. Easy question, basic conversion of angles and finding value. Not more than a minute and a half to solve. Cos theta plus sine theta is equal to root 2 times cos theta. We have to find the value of cos theta minus sine theta. So from here, we have to somehow convert this to cos theta minus. This sign is minus. Cos square theta minus sine square theta is not a property that we have. And therefore, from here only we will try to take out sine theta separately. So from here, if we write sine theta is equal to root 2 cos theta minus cos theta, which means sine theta is equal to root 2 minus 1 times cos theta, which means cos theta is equal to sine theta upon root 2 minus 1. Now, rationalize this by multiplying by root 2 plus 1 and dividing by root 2 plus 1. So this becomes cos theta is equal to root 2 sine theta plus sine theta upon root 2 minus 1 plus root 2. Root 2 minus 1 into root 2 plus 1 will be root 2 square minus 1 square, which becomes 1. And therefore, cos theta is equal to root 2 sine theta plus sine theta, which means cos theta minus sine theta will be nothing but root 2 sine theta. Now, if done properly, looks straightforward sort of a question. But I think overall, if we square this, the expression that we get is a little difficult to handle. And therefore, I'm saying this one probably is a difficult question, about 2.5 to 3 minutes to solve this question. If A lies in the second quadrant, sine, all the sine values are positive. Then 1 minus sine alpha upon 1 plus sine alpha minus. So let us take the LCM first. LCM will be root of 1 plus sine alpha into root of 1 minus sine alpha. Root of 1 minus sine alpha. This gets multiplied here, so we get 1 minus sine alpha. Root of 1 minus sine alpha into root of 1 minus sine alpha will be the square, so root will cancel out. Minus 1 plus sine alpha. So we have taken the LCM and multiplied so that we can add the two expressions. This becomes 1 minus sine alpha minus 1 minus sine alpha. Which is nothing but, and in the denominator we'll have root of 1 minus sine square alpha. A plus b into a minus b is a square minus b square. This becomes minus 2 sine alpha upon, this will be root of cos square alpha. Now, when we take the root, cos alpha will be a negative value in the second quadrant. So from here we'll get minus sine alpha, minus 2 sine alpha upon cos alpha. But cos alpha will be a negative value, and therefore net answer will be 2 sine alpha upon cos alpha, which will be tan alpha. And that becomes my answer, option B. I'd say moderate-ish question. The last step, there is a chance of missing the negative sign and therefore making a mistake. About 1.5 minutes to solve because the steps are pretty straightforward. Cot theta plus cos theta is equal to P. Cot theta minus cos theta is equal to Q. P square minus Q square raised to power 2 in terms of P and Q is. Now P square will be cot square theta plus cos square theta plus 2 cot theta cos theta. Q square will be cot square theta plus cos square theta minus 2 cot theta cos theta. If we find out this is Q square, P square minus Q square, these two terms cancel out, these two terms cancel out, this becomes positive. We get 4 times of cot theta, not cos theta, cot theta, and then cos theta. Therefore, P square minus Q square will be 2 to 4. Squaring this, we'll get 16 times cot square theta into cos square theta. We have to write this in terms of P and Q. Now, if we find the value of PQ, because in the options, all of them are PQ, PQ will be nothing but A plus B into A minus B. So, cot square theta minus cos square theta. Cot square theta will be tan cos square theta upon sin square theta minus cos square theta. This will be cos square theta into 1 upon sin square theta minus 1, which will be cos square theta into 1 minus sin square theta upon sin square theta. Sin square theta is nothing, 1 minus sin square theta is nothing but cos square theta. And cos square theta upon sin square theta is nothing but cos square theta cot square theta. Therefore, the value of PQ is cos square theta cot square theta that we can replace here and get this as 16 PQ. Option A becomes the answer. Level of difficulty, probably moderate-ish, 2 to 2.5 minutes to solve. X is A cosec n theta raised to power n theta, y is B cot raised to power n theta. Then if we have to eliminate theta, from here we can write x upon A is equal to cosec raised to power n theta. Taking the nth root, we'll write x upon A raised to power 1 by n is equal to cosec theta. And therefore, if we square, we can write x upon A raised to the power 2 by n is equal to cosec square theta. Similarly, from here we can write y upon B raised to the power 2 by n is cot square theta. Now, cosec square theta minus cot square theta is equal to 1 minus sin square, cos square minus sin square, 1 minus cos square upon sin square is sin square upon sin square. And therefore, the difference of these two should be 1. And therefore, x by A raised to power 2 by n minus y by B raised to power 2 by n will also be equal to 1. Option B becomes the answer. Again, we are using an identity straightforward. So in terms of level of difficulty, I'd say easy question, about 1.5 minutes to solve. Tan theta is P by Q. You have to find the value of P sin theta minus Q cos theta upon P sin theta plus Q cos theta. Now, this expression looks very similar to an expression where we apply componendo dividendo. We need P sin theta and Q cos theta. If we write this, we can say tan theta sin theta upon cos theta is equal to P by Q. We need P sin theta, Q cos theta. Therefore, multiply this by P, this becomes P square. Multiply this by Q becomes Q square. Therefore, P sin theta upon Q cos theta is equal to P square upon Q square. Applying componendo and dividendo both, we get numerator plus denominator upon numerator minus denominator is equal to numerator plus denominator upon numerator minus denominator. We have to find the reverse of this, and therefore required expression P sine theta minus Q cos theta, taking inverse upon P sine theta plus Q cos theta will be the inverse of the right hand side as well, which will be P square minus Q square upon P square plus Q square becomes my answer. From the options, option B. I think this question also is an easy question. Just one step was required. From there, we are able to solve. And this expression in itself is a giveaway. So not more than a minute and a half to solve. Sine is 3 by 5. A lies in the second quadrant. So sine is positive. Cos and tan will be negative. If sine is 3 by 5, sine square A is equal to 9 by 25. 1 minus sine square A is 9 by 25. Therefore, 1 minus cos square A. Sine square A is 1 minus cos square A. So cos square A is equal to 1 minus 9 by 25, which is 16 by 25. And therefore, cos A is equal to root of this, therefore minus 4 by 5, because A is in the second quadrant. Tan A is nothing but sin A upon cos A, therefore minus 3 by 4. 3 by 5 upon minus 4 by 5. So here I write 8 into minus 3 by 4 minus, would be sec, not C, sorry. Tan B. Tan B is half. B is in the third quadrant, so tan will be positive. Tan B is half. So tan square B will be 1 by 4. We will get sec square. Sec is 1 by cos. We need 1 by cos here. So here I can write sine square B upon cos square B as 1 by 4. Subtracting them from 1. Adding 1. If we add 1 to both sides, we'll get cos square B plus sine square B upon sine square B upon cos square B is equal to 5 by 4. Cos square plus sine square is 1. Therefore, 1 by cos square B is equal to 5 by 4. 1 by cos square B is nothing but sec square B, which will be root of 5 by 4. Taking under root 5 by 4, sorry. Taking under root, we'll get the value of sec B as root of 5 by 2. Secondly, B is in the third quadrant. Cos will be negative, so minus 5, root of 5 by 2. So minus of root 5 into minus root 5 by 2. This is the value that we are calculating. This becomes minus 6. This becomes 5 by 2. 12 minus 12 plus 5. And therefore, minus 7 by 2 becomes my required answer in this case. Option D. Again, we're mostly putting values, but some time might be required to calculate the sine cos values for all both A and B. And we have to be sure about the negative sign as well. So overall, I'm saying moderate, about 2 minutes to solve. Sec theta minus tan theta. Sec theta minus tan theta is a plus 1 upon a minus, and you have to find cos theta. Sec theta is 1 by cos theta. So if from here we're just able to eliminate tan theta, we'll get the answer. Also, if you look at sec theta and tan theta, sec square theta minus tan square theta is 1. 1 upon cos square, sin square, 1 minus. So what I do is I multiply and divide the left hand side by sec theta plus tan theta. Right hand side remains as it is. And therefore, numerator becomes sec square theta minus tan square theta upon sec theta plus tan theta is equal to a plus 1 upon a minus 1. Numerator becomes 1. Take the inverse sec theta plus tan theta is equal to a minus 1 upon a plus 1. To this add sec theta minus tan theta given in the question, which is a plus 1 upon a minus 1. So if we add, we will get 2 sec theta is equal to a minus 1 upon a plus 1 plus a plus 1 upon a minus 1. Taking LCM, this becomes a square minus 1. This becomes a minus 1 whole square. So a square plus 1 minus 2a plus a square plus 1 plus 2a, which means 2 sec theta is nothing but 2 times of a square plus 1 upon a square minus 1. 2 and 2 cancel. Therefore, sec theta becomes a square plus 1 upon a square minus 1. Option this is sec theta. We have to find cos theta, not option A. We have to find cos theta. So cos theta will be the inverse of this a square minus 1 upon a square plus 1. A square, option B will be my answer. Again, the question is not difficult, but getting the fact that we just have to eliminate tan theta uh, is something that may not strike you up front, and therefore the question might take some time to solve. So moderate about 2.5 minutes. Tan 20 is k. We have to find the value of tan 250 tan plus tan 340 upon tan 200 minus tan 110. Tan 250 can be written as tan of 270 minus 20. Tan 340 is tan of 360 minus 20 upon tan 200 is tan of 180 plus 20 minus tan 110 is 90 plus 20. Now 270 minus 20, 90, 180, 270 will be in the second quadrant. And since it is an odd multiple of 90, tan will change to cot 20 and negative value. 360 minus 20 is in the fourth quadrant positive because even multiple of 360, so tan remains tan. Tan 20 becomes the value upon 180 plus 20, again third quadrant, even multiple of 90, so tan remains tan. In the third quadrant it is negative. Here we'll have a negative value. 360 minus 20 is in the fourth quadrant. Tan is positive here and here. In the third quadrant, this will be positive 180 plus 20. So this will be tan 20 minus 90 plus 20. 90 is an odd multiple. Second quadrant, so negative plus cot 20. Since tan 20 is k, 1 upon tan 20 will be 1 upon k. 1 upon tan 20 is nothing but cot 20. Cot 20. Cot 20 degree therefore is 1 by k. Substituting the values, minus 1 by k minus k upon k plus 1 by k. This will be it is. There is a mistake that I have done. In this case, 1, 2, 3, 90, 80, 270. This will be in the third quadrant, so this will be positive. Now, the 270 minus 30, third quadrant positive. 360 minus 20, fourth quadrant negative. 180 plus 20, third quadrant positive. 90 plus 20, second quadrant negative. Now it is fine. So 1 minus k square upon k square plus 1. K and k cancel. And therefore option D becomes the answer to this question. Again, it's an easy question, but you have to be very clear with the signs. Otherwise, there is a chance of making a mistake like I had already done. But if everything goes well, this type of a question should not take more than a minute and a half to maybe 2 minutes at max. So if you look at the overall test, the paper was moderate, about 20 minutes to solve, and we're trying to attempt about 6 to 7 questions. Those questions for me would be 1, 2, 4, 6, 7, 8, 10. Which are these? Definitely attempting this question, even putting values will give me the answer. Here also just finding values of 30, 60, 90. Definitely something that should be attempted. This, I think, was a difficult question. If not done properly, uh, very high chance of getting confused or not counting this question. This, I think, was easy. Just take the LCM, multiply, and it flows from there. Negative sign was to be remembered. This again may happen, might not happen, depending on how comfortable we are working with the last term that we had to solve. So, not counting this as a sure shot question. This was a simple question, just basic identity was to be used. Again, the required expression was a giveaway, component of dividend, and therefore doable question. This also could have been done since values were to be calculated. This question, again, if we are able to understand that tan theta is to be eliminated, the question is attemptable. Otherwise, not a very easy question. So I would not count this as a sure shot question. This is values, we just have to find the basic values. Tan 20 is given, just angles had to be readjusted. So definitely a doable question. So from 1, 2, 4, 6, 7, 8, 10, we'll be able to find our 6 to 7 question.